Hello beautiful people and welcome. In today's video we are graphing cosine. Now I went ahead and pre-drawn a unit circle and there are specific values that we are going to be focusing on when we are graphing the parent function, which is cosine of x. Now I did one cycle in radians, so we start out with 0, pi halves, pi, 3 pi halves, and then we're back to a full cycle at 2 pi. Each of these angle measures have a location, which is our x and y, so x comma y. Now we are graphing cosine, so we're going to be focusing on the x values here. Let me highlight that. So we have 1, 0, -1, and 0. So the way that we create our, kind of like our t-table, our inputs are our angles, and our outputs are our values. So the parent function, the basic, is cosine of x equals y, or you can also call it f of x. So for example, if we have cosine, and I'm writing cosine here, our angle is 0 radians, then cosine of 0 is 1. If we have cosine of pi halves, cosine of pi halves is 0. Cosine of pi is -1. Cosine of 3 pi halves is 0. And we are back to cosine of 2 pi, which is 1. So if we were to graph that in a regular x and y Cartesian plane, we start out with, let me switch to cancel. We start out with 0 and go up to 1. Then we have pi halves. Now the way that I graph sine and cosine, tangent I do a little bit different, but sine and cosine is I start with no cycle, then a full cycle. So here is 0. These are our angles. And here's my full cycle of 2 pi. Notice that my full cycle and no cycle, they're going to have the same value because they are in the same location. Then I go in my halfway, my half a cycle, and half a cycle goes down to a -1. Then I go to my quarter cycle, so I have a quarter cycle here at pi halves and 3 pi halves. And they are both at 0. And what you'll notice is we have, I'll do a little dotted line, this is not an asymptote. This is our maximum value on a cosine, and this is our minimum value on a cosine. And then we do have a midline. Now again, this is our basic parent function, so with transformations, our maximum, our minimum, our midline will change. So we'll our start, our end, and our distances. Let's go ahead and connect. Smooth curves, no sharp V's. I also am not going to be crossing that maximum. I'm going to touch the maximum point, curve down, and arrow, curve down, and arrow. Now, what ends up happening, this is one cycle. Let me go ahead and close that here. One cycle for cosine, one full cycle. But we can, and I will extend this in a dotted way, extend this out, and you'll notice that we end up kind of having the same thing that we did as a cosine, just shifted. Okay? So, sine and cosine do have a relationship with each other. If we take a look here, you'll notice that sine and cosine do have repetitive values. 1, 0, 0, 1, -1, 0, 0, -1. So they're going to kind of look the same, but they're not the same, right? Different parents, different functions, different ways that they look. So this one's going to look a little bit different. So characteristics of a positive cosine is that it starts and ends on its maximum when it's positive. The middle will drop down to your minimum when it's a positive function. And then your quarters, I call them middles of middles, your quarters are going to be on the midline. So here in purple is what your cosine wave looks like. Everything past here is just a continuation of more than one cycle, either going forwards or going backwards. So let's talk about transformations. So let's say we have y, let's stick with y. You can choose f of x if you'd like. A times cosine of b of x minus h, close it, plus k. Again, these are going to be repetitive from your sine wave, your sine graphing that we did. You're going to take the absolute value of your A value. This is your amplitude. This is your amplitude. And your amplitude is the distance above and the distance below your midline. So distance above and distance next, we have our cosine. So cosine, I'll do this in a different color, so I'm going to ignore that. And then I'm going to jump to k. Since we just were talking about our midline, k is our midline. Remember, k is for keep. And this is our vertical shift up or vertical shift down. Next, you'll notice that we do have a b value that is factored out. And I do have a hint for you for your b value. If you multiply the original, I say it's a c value, by the reciprocal, you get h. And I'll show you that in a little bit. After you factor out b, you're going to use b to find your new period. Since we are talking about transformations, you won't have, sometimes, what your original period is, which is 0 to 2 pi. Your distance between your start and your end is a cycle period. Sometimes that's going to be different. And your formula is 2 pi divided by your b value. Now your h value, after you factor out, this is called your phase shift. It's our start value. I like to see this phase shift, but it's our start value. Remember, h is opposite of what you see. And then I promised you a little bit of a cosine description. So again, we have a positive cosine. If a is positive, we have a negative cosine. If a is negative, it is dependent on whether you have an increasing or a decreasing function. Now for us, for a cosine, if you have a positive cosine, that means again, you're going to start and end on your max value. If you have a negative cosine, you're going to start and end on your minimum. Okay. And then I also promised you a guide or a hint on how to deal with the factoring of b. We'll do that on a separate page. All right, let's go ahead and have some steps. And I'm going to go ahead and show you these steps. I'll write them out. These are exactly the same steps that we did for graphing sine. There's just going to be a little bit more organization to this, I hope. And we're going to jump right into an example of cosine. So let's do y is equal to negative 2 cosine of 2x minus 11 pi 6, close it, plus 2. Step number 1, is you're going to factor out b. So b is going to be your number that is attached to your x. Now, identifying b is going to be rather unchallenging. It's just whatever's attached to x. But factoring it out actually becomes a little bit more challenging. So 2x minus 11 pi 6 is what we have. And what we do is you have two options. You can create a mini equation to say 2, this is your b value, times h is equal to your, this is what I call c, but your given value. And then you continue to solve. Solve for h. But unless you know to multiply by the reciprocal here to solve, or use a calculator, again, that might be a little bit more challenging to you. So my hint is always take the reciprocal of your b value. Hint. You're going to multiply the c value. And again, the c value is what is given to you. And it's not always called c. I call it c. It's just a variable representing a value by the reciprocal of b. So what we have is a 2 for b, which means the reciprocal is 1/2. So our given 11 pi 6 is going to be multiplied by the reciprocal of 1/2. So we have 11 pi 12ths. Now be careful with this value. You still want to put this back into the equation. So you're going to use to rewrite the equation. So what I mean by that is we have a given equation. We just removed out that b. We have the 11 pi 12ths. We want to put it back into the equation, just rewritten. So now we have y equals -2 times the cosine of 2 factored out. So now we have 11 pi 12ths as our true h. So I'm going to just highlight that. We still want the original parentheses, and then we want the factored. Okay, once we have that, let's actually put that in a little thinking bubble, because this is important. This is what we want. We want to rewrite. From here, step number 2, we're going to move a little bit faster now. We do typically spend a little bit of time here. We're going to do a quick little, I was going to call it a T-chart, but just a table. We're going to identify the midline, the amplitude, and the phase shift. Your midline is your K value. Oh, I forgot my K value. Let's squeeze that in. Your midline is your K value. Your amplitude is the absolute value of A. And your phase shift is your opposite of what you see H. So we're taking your k value, so our midline is at +2. Amplitude is the absolute value of -2, so 2 is your A value. And your phase shift, opposite of what you see H, you see a -11 pi 12ths. That means you have a +11 pi 12ths. And this value here, this is your start value. That's your start value. After you identify those three things, step number 3 is going to be your new period. Your new period formula is 2 pi over b. It's always 2 pi because originally in the parent function, our period, our one cycle is from 0 to 2 pi, so we use 2 pi. So we have 2 pi over our b value. B value was 2. So that means pi is our new period. Next, we find our end value. And I'm going to run out of space, so I'm going to move on to another sheet of paper. Step number 4, just kidding. Step number 4 is our end value. Now again, we do have a little bit of a formula. It's not technically a formula, it's just steps. You're going to take your start value. You're going to add to that your new period. And you're going to get an output of your end value. So for us, our start value was, I'm taking a look here, start value 11 pi 12ths. I'm going to add to that our new period of pi. And now you notice that I have to create common denominators, which is common. You most of the time need to do this. So I'm going to multiply 12 and 12. So we have 11 pi 12ths plus 12 pi 12ths. So we have 23 pi 12ths as our end value. Okay. Step number 5 is you're going to calculate the distance between what I call each jump, but it's the distance of your new quarter. You're going to calculate distance between each x value. And again, mini formula, and that is your new period times 1/4 equals your distance. And this 1/4 is always 1/4. That part doesn't change. So for us, we have our new period of pi. We're going to multiply that by 1/4. So that means our distance is pi 4ths. And then we have one more step, is we want to make sure that everything is in common denominators. And the three values that we want to check for common denominators, and that's going to be your start value, your end value, and your distance. Our start value was 11 pi, change markers so we can stand out, 11 pi 12ths. Our end value was 23 pi 12, so everything good there. However, if you notice, our distance is in pi 4ths, so we need to convert that into common denominators. So I'm going to multiply top and bottom by 3. So we have 3 pi 12ths as our distance. So even though technically our distance is pi fourths, in order to use it in graphing to make our life a little easier, we need all of these 3 values in common denominators. Okay, I don't have that much space, maybe what? I don't know, 5 fingers, 6 fingers. Here, it's enough. Okay, it's enough of space. I always want to take a look at these values. This is a positive value at 11 pi 12ths. This is a positive value, and distance is always going to be positive. Because of that, I'm not going to create space in my denominator. Just kidding. I'm not going to create space in my negative x values. Not sure why I said denominators a few moments ago, but then, life happens. We want more space in our positive x values. So negative needs to be on the smaller side. We're not going to technically use that. Next, where you start is technically up to you, but we're starting at 11 pi 12, so I'm going to assume 11 pi 12 is here. Where you end is going to be 23 pi 12. Okay. I marked this out just to show you our start and our end, but I'm actually going to go back to step number 2 and look at my midline and my amplitude. My midline is at 2, my amplitude is 2. So here's 1, 2. I'm going to do a dotted line. This is not an asymptote. This is my midline. I probably will need to move that word here. Then I'm going to go up 2 for my maximum, and I'm going to go down 2 for my minimum. Now, the reason I am going up and down 2 is because my A value, my amplitude, is 2. Okay. Next, I'm going to do a little quick dotted line here and here. Let's erase. Oop, no eraser there. Let's go and erase that. Again, these are not asymptotes. This is just me showing you where your start and end is. So you create this kind of rectangular boxed region where that's going to be your one cycle. Next, we're going to use the distance. We used our start, we used our end, and now we're using our distance of 3 pi 12ths to calculate the next x values. So 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. And this should give you, using this method, this should give you your required 5 values for one cycle. Now, in a different class like pre-calculus, you might need more values to create more than one cycle. You just keep counting. If you want 2 cycles, count more. 3 cycles, count more. 4 cycles. You can always add distance, and we can always backtrack as well if we wanted to go towards the negatives. Next, what function do we have? We have a cosine, but we have to be careful because what type of cosine do we have? Our equation, here's our thinking bubble, our equation shows us that we have a negative cosine. So with a negative cosine, we're going to start and end on the minimum values. So here's our dotted line for the minimum. I'm going to start on the minimum values and end on the minimum values, which means my middle goes all the way up to my maximum, and my quarters, my middles of middles, are going to be always on the midline. We're going to connect, smooth. Now again, these are not asymptotes, but you cannot go above your minimum or maximum values. But you can continue, and you must continue past your start and end, because these are not asymptotes, these are just markers. So anything past your start will continue another cycle, anything past your end will continue another cycle. So this is graphing cosine with transformations using 5 steps, 6 technically, that make this a lot easier than just going straight into solving, okay, or graphing. Let's do another quick example, and then I will let you go. Since we did a negative, let's do a positive. I'm going to show you one without the b value since we had one. With the b value, y is equal to 3 cosine. Let's do x minus pi. Let's do a plus. Plus 1. And again, I'm going to try to work a little bit quicker. Step number 1, factor out b. So we're taking a look in front of x. What is our b value? Our b value is 1. There's no factoring needed. I still want to identify what b is for our next step, our step number 3 technically. Table. We want our midline. We want our amplitude. And we want our start value, or phase shift. Midline is your k value, amplitude is the absolute value of a, start value is opposite of what you see, h. We have y is equal to 1, your k value, amplitude is absolute value of 3, and opposite of what you see is negative pi. Okay, step number 3 is going to be your new period. Two pi over b. This is why we needed our b value in step number 1. Just 1, so we stay with the same period of 2 pi. Step number 4, you're going to calculate your end value. End value formula is your start plus your new period, and that's going to equal your end value. Our start value is negative pi, our period is 2 pi, so our end value is at 1 pi. That makes it a little easier, no common denominators, nothing. Step number 5, we're going to calculate the distance. And again, this is the distance between our x values. Formula is you're going to take your period, your new period, you're going to multiply that by 1/4. And again, this is always 1/4. And that's going to equal your distance. Your new period, what was it? 2 pi. 2 pi times 1/4 is, put a 1 underneath that, 2 pi fourths. So that means my distance is at pi halves. And 6 is check for common denominators. Three values that we want common denominators for. We want our start, our end, and our distance. Our distance is at pi halves, our end is at pi, and our start is at negative pi. So if you see here, we will need to create common denominators. I'm going to multiply these by 2. So my start is now at negative 2 pi halves, and here is at 2 pi halves. And now we're ready to graph. Again, take a look at your values. It looks like I am going to need the negative portion of the x-axis because I do have some negatives. Where are we starting? We're starting at negative pi halves. So 1 pi about here, 2 pi halves, sorry. I said negative pi halves, which is incorrect. It's negative 2 pi halves. And about the same distance here at 2 pi halves positive is our end. Let's go back to step number 2. Our midline is at 1. Extend that out. Our amplitude was at 3. So 1, 2, 3 jumps. We have our maximum value at 4. And we have 1, 2, 3. Our minimum value is at negative 2. Again, these are not asymptotes. These are just markers for us to help zone in where one cycle is going to be. So one cycle is going to be right in here. Next, we're going to use our distance. Our distance is at, let me make sure I'm looking at the correct example, pi halves. So we're here. And we're subtracting. If we have the same common denominator, you don't have to worry about the denominator. Just look at the numerator and add, subtract. So if I'm at 2, I'm going to have 1, 0, 1. Again, I am counting up, but also counting down per se, because this is negative. Negative plus 1 is a negative 1. So negative 2 plus 1 is a negative. Thank you for saying that. Negative pi. Add another 1. That's at 0. Add another 1. That's at 1 pi halves. Add another 1. That's at 2 pi halves. Now we will need to go back and simplify these. I did notice that I didn't simplify them in the other example. We do need to simplify those. But let's go ahead and look at our function, our equation. We do have a positive cosine. That means we're going to end on the maximum value. So here's our start. Here's our end. That means the middle is going to go down to the minimum value. And our quarters, the middles of the middles, are going to be on the midline. I don't recommend doing the curve in pen. Make sure you have smooth curves. And again, these are not asymptotes. So you're going to continue, but you're going to curve down because our maximum is our maximum. We can't have anything higher than that. And so this is your cosine curve. Let's go ahead and simplify this. This is just negative 1 pi. You can simplify your fractions, or you can look and see what your start and end values were before you change the common denominators. And then I am going to go back to our first example and notice that we have things like 14 and 12. So we're going to divide that by 2 and say 7 pi sixth. This is good. And then this one, this is 20, this is 12, so I'll divide by 4, 5 pi thirds. All right, beautiful people, thank you so much for hanging in there. I will do a separate video for more examples on sine and cosine. Thank you.